Okay, guys, so let's look at the next question. A rectangle around Utah is about 270 miles wide and about 350 miles tall. The upper right corner that is missing is about 110 miles wide and about 70 miles tall. Number 1 is asking us to make a scale drawing of Utah where 1 centimeter represents 50 miles. Then it wants us to make a scale drawing of Utah where 1 centimeter represents 75 miles. Number 2 asks, how do the two drawings compare? How does the choice of scale influence the drawings? So if you guys already noticed, I have my information separated in color because I want my work organized and neat. So I'm going to annotate my problem and then we will get started. So what I want to do is I want to go to the problem and find some of Utah's dimension and underline it all, okay? Because that's imperative. And then for the first one where it's saying 1 centimeter represents 50 miles, that's going to be in red. And then the other one where it says 1 centimeter represents 75 miles is going to be in blue. Now, granted, I know I do have a ruler on this iPad, but the ruler does not have numbers, and I'm not sure if it's a metric ruler or a 12-inch ruler, and I don't want to assume. So what I want to do is I'm going to do the calculations with you guys, but I'm going to challenge you guys to do the work at home yourself and to see if you could create a scale drawing on your own, if you have a ruler, of course. So let's look at the first one. All right, what I want to do is I want to convert my measurements or my dimensions of Utah. And how I'm going to do that is I'm going to divide the measurements divided by 50, which should give me the centimeters measurements for my scale drawings. So I'm going to start off 270 divided by 50, 350 divided by 50, 110 divided by 50, 70 divided by 50. So, I'm not sure if you guys math teacher taught you this, but if you see a 0 in the numerator and the denominator that's at the end of the number, that can be scratched out. That's like us dividing by 10. So I can scratch out all the zeros. Okay? So that was just a quick way for me to simplify it. And now it is 27 divided by 5, 350 divided by 5, 11 divided by 5, and 7 divided by 5. So now you can ask yourself, well, how many times can 5 go into 27 without going over? And what I mean by that is I'm basically dividing like this in my head. How many times can 5 go into 27 without going over? So I could divide 5 divided by 27, and then 2's left over, which means if I convert it into a mixed fraction, it will be 5 and 2/5 centimeters. The next one would be 35 divided by 5, which is 7 centimeters. The next one would be 11 divided by 5, which is 2.5 centimeters. And the last one, which is 7 divided by 5, would be 1.4 centimeters. If you wanted to leave it in fraction form, you could have put 2 1/2 centimeters. Or you could have put 1 4/10 centimeters. Okay? So now for the next one, I want to do the same thing, okay? I want to divide 270 divided by 75. 350 divided by 75. 110 divided by 75. 70 divided by 75. Okay? So when I do that, I should get, and I'm going to write this down, which I'm using my calculator. You can use your calculator at home. I'm just using the calculator just for time's sake. But it will be 3.6 centimeters. The next one will be 4.6 centimeters, or it's a continuation. Or you could put 4 2/3 centimeters. Okay. Then the next one would be 1.46 centimeters. And the next one would be 0.93 centimeters. Okay. So what you guys can do at home is to use these measurements, my calculations, to create the new scale drawing. And I want you guys to answer number 2 on your own. How does these drawings compare to each other? What influence did the scale have on these drawings?